I'm humbled that there are so many of you who are eager to be disappointed this morning, so thank you. Basically, this talk is kind of about kind of going back over some older web performance practices that are commonly practiced, and just kind of seeing if they're still important, still useful today, why are they not useful, etc. And I'll expand on that in a second. My name is Ben Vinegar. That is my real last name. And I go by Bentelgen on Twitter. I co-authored a book a couple years ago called Third-Party JavaScript. It's a book that kind of teaches people how to sort of write functional third-party scripts, put them onto other people's pages, analytics scripts, widgets. I used to work for a company called Discus, embedded comments. Maybe you're familiar with that. And a lot of what's in that book came from my working there. I'm also a contributor to a book that just came out this summer called Beautiful JavaScript from O'Reilly. And I talk about Backbone or something, so you're probably not that interested in that. Today I work for a company called Sentry, and we're sort of like we're an open source company. We make an open source tool, and we productize it. It's crash reporting or sort of like exception tracking. Works with client-side code, back-end code, every platform. This is the plug section. If you'd like to find out if your apps are crashing in production and you'd like to debug them quickly, you should go check out Sentry. So that's all I have to say about that. So who here is familiar with the term cargo cult? Okay, not too many hands. I'd heard this a lot of times, and I kind of used it, but I didn't really understand where it came from or what it meant. And the origin of it, I think, is a really fascinating story. Basically, in World War II, the U.S. military was set up on sort of like all these South Pacific islands outside of Japan. And so they had set up like temporary air bases. And these South Pacific Islanders kind of like watched as they would go through these rituals of, building bases, marching up and down the landing strip, and then planes would fly by and drop cargo onto the islands for the troops stationed there. And when the war was over and the military left, the islanders actually created cults whereby they wanted stuff from the sky too. So they tried to recreate kind of all the rituals that they saw the airmen doing. So they created fake boxy airports, and they would try to dress like they saw military people would. So this expression of cargo cult kind of came up, I think it was like the 60s or 70s. I don't know if you're familiar with Richard Feynman. I really just know his face, and I know he's on books. But he gave an address at Caltech where he was a professor, and he wanted to warn people from cargo cult science. He was observing that a lot of people were just taking kind of like work that had been done before them, and they were just kind of using that data, just using that as a given without really going back and kind of figuring out whether it still applied, and often it didn't. So today, I kind of think you've probably heard cargo cult programming, but there's also sort of this idea of cargo cult web performance where, I've definitely done this where it's I get on a web project and I just, I go in and I'm just going to do all the things that I did before because that's what makes it fast. But variables are changing, just like the, South Pacific Islanders didn't quite understand the full, they had some missing independent variables in their scientific experiment. We have browsers that are changing, network landscapes that are changing, browser engines that are changing. So, what you did a couple years ago maybe doesn't apply anymore. So how did we get here? How did we get to this place where we're just kind of doing this all the time? One reason is deprecated books. I'm a big fan of these books. I've read all of them, starting with high-performance websites and then even faster websites, 2007, 2009, by a fellow named Steve Souders. He's the guy who built Why Slow at Yahoo. So you may have used his work before. And then in 2010, sort of a more JavaScript-centric book by Nicholas Zakis called High Performance JavaScript. 2007, 2009, 2010. These are the performance books for the web, and they're super old. But they're still bestsellers on Amazon. So we're buying these books, we're taking the stuff that's in there, and we're applying them, and they're not necessarily. Some of the stuff in there is not necessarily true anymore. Stack Overflow answers. Didn't expect that response, but I guess everyone knows. Basically, I was having a conversation this weekend about how I feel like Stack Overflow is the experts exchange of today. When it came out in 2009 or 2010, we got a whole bunch of great answers for that time, that era, and those got voted to the top, and those are the best answers. But now they're not correct necessarily anymore, and some of them can be really confusing. This is an example of an answer. We'll come back to this, but somebody's asking, what is the fastest way to write a JavaScript loop? And in bold, currently, the fastest way is to do this. That answer was from 2011, and it was maybe edited in 2012, right? So I don't know, maybe just at a glance, you look at this answer and you think that's the fastest thing. Yeah?
That looks like February 12. I would assume if it's not giving an apostrophe year.
Oh, yeah, edited. But it hasn't, sorry, you're right. It is from this year, yeah. But the answer didn't change. Okay. Let's say. We'll come back to this. Analysis tools. If you've used YSlow or Google PageSpeed, has anyone used these tools before? Sometimes they actually have, Google at one point had 2 versions of their PageSpeed. They had the browser extension, which you may have used, and they also had a web-driven sort of tool. And they actually gave different answers for a time, because one was updated with sort of better practices, and the older tool, I think was the extension, had older practices. So you would get completely different scores depending on which one you used. So if you had used the older one, you might have just been following sort of bad practice. These tools themselves are kind of out of date. YSlow is now an open source tool. You can get it on GitHub. And if you look at sort of the commit history for this tool, not much has happened in the last couple of years. And most of those are just documentation updates, 2014, 2013. Maybe you go to live websites and you do view source and you kind of look at what other people are doing and you think that's the wow, this is a big company and they're pretty respectable, so I'm going to do what they do. But they might be behind, and this sort of permeates more of this. This is just random source code from Facebook. Don't attempt to look into here. And then there's also conference talks like this one, and that's why I sort of had this really aggressive expiration date on this talk, because I'm going to say some stuff that maybe come next year won't be true anymore. Probably not. But let's give it maybe a year or two, but you get the idea. So specifically, I'm just going to talk about 3 really specific things that have changed. Maybe you've used this, maybe you haven't, but I think they're still kind of interesting just to talk about. I hope so. The first is hostname sharding. This is where you sort of use multiple domains to kind of coax more parallelization out of the browser. The second thing is for loop array length caching. So this is like JavaScript. This is how do you write a JavaScript loop? What is the fastest way today? And then another thing is dynamic script insertion. This is probably something you've used even if you're not aware of it. It's if you've ever taken a Google Analytics snippet and just copy pasted it into your code. Usually that snippet has it's like a blob of JavaScript. It's var x equals create element script and kind of appends it that way. Even how that works today has kind of changed. So those are the 3 things we're going to talk about. I really don't try hard to look on Flickr for cool photos. So hostname sharding. The origin of this is kind of interesting. When the HTTP spec first came out, it basically said you can open at most 2 connections per origin, per domain. The reason that they did this is when the HTTP spec was first created, they were worried that if a browser just opened up all these connections against a server, they would just take down web servers, right? This is early days of the web. So they wrote that into the spec. And what happens if you have, if you imagine that you have a web page and all these assets and it only does 2 connections at a time, you get kind of this network waterfall graph where I'm going to download 2, then I'm going to download 2, I'm going to download 2. It can be really slow. In a perfect world, if we had sort of more parallelization, we'd get something like this. And this is absolutely what happens today, and we'll come back to this. If I had 4 connections in my browser per sort of domain, I would get way more parallelization. And you can notice how this graph kind of finishes faster. The web page would finish faster, people would see it. And obviously with 8, even faster again. But for the longest time, browsers did not do this, and not even that long ago. So we kind of came up with this hack. And this is a hack that is talked about in that 2007 High Performance Websites book, which is, hey, did you know that you can have multiple domains for kind of like your assets? And the browser will be like, oh, this is a different server. I'm allowed to open up more connections against that server. So for a long time, we would have, I assume that you've all seen this. You've seen www1, www2, www3, CDN1, 2, 3, 4. This is what web developers were trying to do. They were trying to coax more parallelization out. There are still websites that do this. When I was developing these slides, it's definitely like a couple months old. I was going through like kind of the Alexa top 100. Who are people who are doing this? And there's still kind of a lot of big sites, and sometimes a lot like eBay, Business Insider have CDN 1, 2, 3, 4, 5, 6. Netflix at the time that I looked, all the way to 11, which is kind of interesting. We were so convinced that this was like such a cool practice, very useful practice. There is a Stack Overflow question out there that I thought was really funny, which was this person was so convinced that parallelization was great, so they had created a build process where they were generating a unique subdomain for every single one of their files for maximum parallelization. And we'll talk about why that's a bad idea. This is not a big deal anymore for a bunch of reasons. One, and just the simplest of them all, is that browsers parallelize a lot more today. So modern browsers parallelize anywhere from 6 to 13 connections per server at a time. And even you might be thinking, like, well, why don't they all do 13? Why don't they do 20? Why don't they do 15? Basically, browser vendors have decided there is a sweet spot, just like there isn't, why you shouldn't have a unique subdomain per file. There is sort of a sweet spot that I think like a lot of browsers have landed on. So that's the way it is today. Even in today's world, even with these browsers that parallelize a lot, if you rolled out 6 different CDNs with different origins, internally browsers actually cap a lot of requests anyways. So Chrome, if you want to try this experiment, you open up all these different domains, you'll actually notice that it will download at most 10 resources of a type anyways. So it will just stop. You can't trick it, I guess is the way, one way to think about it. I wrote images here, but it's actually any asset of a type, JavaScript file, CSS file, etc. Another reason why this is not such a big deal, is the rise of HTTPS. We've probably all observed HTTPS is a bigger deal now. More and more and more websites are HTTPS only. There's a cost, there's an overhead when you open up a new connection on a domain. And that cost is bigger when it's over HTTPS. Now there's like a secure handshake. There's this TLS negotiation. So while that was sort of like a cheaper operation when we were just using HTTP, more expensive over HTTPS, you actually want to avoid having a whole bunch of domains if you can. HTTP2, I'm not really going to talk about it too much because that's like it's this whole other world. But HTTP2 is the new HTTP spec. It really changes the game for how files are served to browsers. And if this technique was on its way out before, HTTP2 will just sort of put that nail in the coffin as well. I'd encourage you all to kind of like look into that if you get a chance. Even in 2013, Steve Souders, who first sort of like wrote about this in that 2007 book, has even come out and said, I said 4 or 6, that was really cool back then, but in 2013 he said maybe at most 2, and I have a feeling that now that'd be 1 today. This isn't just hypothetical. There's a case study out there. Etsy ran an experiment where they were using 4 distinct CDNs for images when you browsed Etsy. And they were like, hey, what does this look like if we went down to 2? And they found that across the board, pages got faster, especially on mobile. Because I think what they learned was that while your desktop browser can handle all these like multiple connections, multiple domains really well, mobile browsers not so much. So who knew? And I think that's important because, again, this was a practice that was created at the time when we did not have, supercomputers on our persons in our pocket, right? Earlier I showed you a table of how this was still happening. It's only fair to say that, yes, there's a lot of websites who've massively reduced this. Netflix is at the top with an asterisk. And sort of the asterisk I found was that over HTTPS, Netflix uses 1. Over HTTP, they may not allow HTTP anymore, but over HTTP, they had up to 11. So even at some point, they were noticing, there's a difference when somebody accesses over HTTP versus HTTPS. So that's all I'm going to say about hostname sharding. We'll do questions at the end if you have any questions about that. So let's talk about looping, specifically JavaScript looping, and whether you want to cache the array length of an array when you're iterating over it. I'm hoping that this is a pattern that people have seen or they use, perhaps in their own code. It's maybe not easy to spot, but these two snippets are a little different. In the first one, I am just iterating over array.length, the property of length on array, on the R variable. And below, I'm assigning length to a temporary variable, len, and then I'm comparing against that. Okay? For a long time, there was a lot of material out there that was, you absolutely have to cache this length property. JavaScript engines are terrible. This article, went so far as to make fun of you if you did it by accessing the length property every time. This is how you don't do it. And this is from 2009. If you do like a code search on GitHub, this is like this pattern of caching array length is super common. I'm sure this is not the most accurate search in the world, or it's pretty specific, but even I found almost 300,000 instances of this line of code. And again, currently, going back to the Stack Overflow answer, if you ask Stack Overflow, what is the fastest way to write a loop? Currently, it's caching that length property into a temporary variable, according to this post. But is that true? So today, in like modern browsers today, not really. This is me dragging out every browser. The versions are just a little bit old because I already did these experiments a few months ago. Probably the last browser that really sort of like got a benefit from this was IE8. And I don't know. Today, I work on a product that doesn't work on IE8. I've accepted this. I don't know about the rest of you. So if you really care about IE8 and, maybe that matters. But I don't personally think so. But I don't want to just come here and say, oh, it doesn't matter anymore. That's it. Oh, this is the end of this section. Why is this true? It seems like caching that length property should be faster. It's like I don't have to do an object lookup. Sort of like a property access on an object. It seems like it should be faster to do it that way. So what changed? And it's pretty simple. It's that browser JavaScript engines basically know how to optimize this pattern for you. So there's a Google Chrome engineer out there named Vyacheslav Igorov. I hope that I haven't butchered his name. And he has a tool that he's developed called IR Hydra. And what this tool does is it actually shows you like an assembly-like interpretation of what your JavaScript code looks like in V8. So you can sort of like feed JavaScript code into it and be like, oh, this is what V8 does. And he wrote a very long blog post about like what happened to this pattern, what happened. And basically, he ran this, sort of like those two kind of code samples through. And it's going to be hard for you to kind of like read this. That's okay. The takeaway is that actually the output is identical. Okay? So these are the two versions. A couple registers change. And actually what you really see there kind of like flip up and down is it's showing the original code in lines. That's really what's kind of changing. But the code is basically the same. So it doesn't matter what you write. The underlying JavaScript engine is going to make it faster for you, is basically the takeaway. And it's not just V8. It's basically, this is a really common pattern. All the browsers kind of do it. And I think the lesson here is like, if you think that you can trick the browser using such a really like trivial kind of thing, you know what I mean? Like pretty simple. Ha ha ha. I'm just going to take this variable over here. At this point, you got to believe that the JavaScript engine can do that kind of stuff for you. There. So maybe we shouldn't worry about it so much. But to be completely fair, I was testing this on like every browser. And I looked at mobile browsers, and there was like a minute difference on mobile browsers. I need to talk to someone about why this is, but I think it's such a tiny amount that you really shouldn't worry about it today. Another thought is, I know there was an ES6 kind of like tutorial talk that maybe some of you sat in on. One thing that I don't think that was brought up is that there's actually a new way of looping in ES6. Instead of doing the whole for I of, you can actually just iterate through all the values of an array now using the of operator. So, probably in the future, it's not even going to be either of those code examples. You're probably going to switch a lot of them to this. And so that's what I have to say about looping. The last thing that we're going to go over is this dynamic script insertion pattern. There's not really a good picture to capture what that means, so this is a plane that says dynamic on it. It's what Flickr gave me. So who here is familiar with the concept of like a blocking script include? Okay. I'm getting 4 hands. That's okay, we're going to go over it. A blocking script include is basically is just a script tag with a source attribute. It's the default script tag. What that means is browsers will wait until JavaScript code downloaded in this fashion is downloaded, parsed, executed before it will actually go and download other assets in the page. Okay. This waterfall graph is intentionally old. This is from like IE6. This is from Steve Satter's blog. To try to demonstrate to you what browsers look like for like this exact example. So this is the same code. Basically, if you can follow along, it's a little small, but the second blue line is this vendor.js file. It downloads and parses, and that big white gap is slow computers, slow browsers trying to munch through JavaScript. And then the next app.js starts, and then we download that, munch through that, and then we download CSS and images. Browsers are a little more intelligent about this. We'll get into it. But at the time, that was the situation. So we came up with a hack. And this hack is that if you create a script element in JavaScript, okay, and attach it to the DOM, it would have this sort of like characteristic that it was kind of like out of band, and the browser just kind of treated it as its own asynchronous thing, and would download in parallel. So if I kind of replace those like script examples here with this, you'd kind of get some nice parallelization. I've totally adopted this graph. We talked about how browsers limited parallelization at the time. Let's just ignore that. So for a long time, this is an article from 2009. This was regarded as like, this is the way that you should load your JavaScript. If you've ever used a tool like Require.js, Lab.js, under the hood, they're doing stuff like this. In my book, plug my book again, I also wrote that this is a pretty cool thing. You all should be doing it. And you've almost, like we discussed earlier, you've almost certainly used this even if you didn't know it. If you've copy-pasted like a snippet from Mixpanel, Google Analytics, WordPress stats, Discuss, Facebook comments, etc. They're all doing this. But there's a problem that we just sort of all ignored over the years, and that's the concept of the CSS object model. We're aware of the DOM, the document object model, right? It's sort of like HTML maps to DOM. This is like a JavaScript API. I can mess with it. There's a CSS one as well, the CSS OM. And it kind of looks like this. If you look at this example below, you can query the CSS OM just as you can query the DOM. You can say, hey, what is the get computed style of this body? What style is applied to this? So that's the CSS on. And just like in that sort of like example where the browser would wait for the scripts to execute, the browser won't actually let you execute this JavaScript code until CSS finishes, which makes sense, right? Who knows what that CSS is going to do, right? If I want to get the computed style of body, well, I need to download that CSS file. I need to apply it. Now I can query it, right? So internally, the browser will just sort of wait. What this means is that if you've ever done the kind of Google Analytics script, this dynamic script insertion, and you've placed it below a CSS file like this, because this inline script, like the browser doesn't necessarily know what's inside this block of code. It doesn't know that you're not going to query this CSS object model, so it's going to wait. Before it even gets to execute this like cool asynchronous script, it's going to wait for CSS files. So this is an example where it's hard to see. You just kind of pay attention to like the bar charts. This is an example where I have sort of like a long loaded CSS file, intentionally slowed down to be like 10 seconds, and then a bunch of dynamic script insertions after it, 2 of them. What happens is you can see that the CSS file is fully downloaded, executed before it even starts downloading the JavaScript files. Okay? Is this making sense? Okay. The funny thing about this is that if we had used a standard blocking script, the browser will go, oh, I know what these are, and it will actually try to do some eager loading and try to prefetch the files. So in this example, this is Firefox. It doesn't prefetch both, but it prefetches the first one, and it just kind of hangs on to it. So it downloads the file, and it doesn't execute it. It knows that it has to wait for CSS, so it just kind of holds on to it, waits for the CSS file to finish, then it executes the JavaScript. But that's faster, right? Chrome is even more eager. It downloads both files together in this example, right? So this is using the deprecated kind of style. And it's really funny, but the web community actually didn't know about this at all until about 2014. It just never crossed anybody's mind. Nobody really like looked back and thought about it. So this is Ophelia. This is Ophelia. I guess I combine fellow and Ilya. This is a fellow by the name of Ilya Grigorik. He's actually from Waterloo, I think. He used to work here in Toronto. And he works for Google today, and he has a web performance book out there that just came out, I think, this year, about browser networking. So if you're really digging this, you should check out his book. It's more networking focused than sort of the other books. He basically goes so far as to say that this script insertion kind of like pattern is actually harmful. And he has a quote in there which is like, have we been doing this wrong the whole time? Like, he couldn't believe that nobody noticed this. The good news is that another thing has been developed. This came out with HTML5. It's called the async attribute. Okay? The async attribute is basically trying to do what that inline asynchronous snippet is trying to do. It's like, download this file. I'm not going to access the CSS object model. I don't care what the state of your website is when this file is downloaded. Just download it, execute it as soon as it can be done. Okay? And if you use this for your code, it avoids all of these problems. So this is that example again in Firefox, and you can see that all 3 resources are downloaded in parallel. The JavaScript, as soon as the JavaScript is executed, even though the CSS is still churning away, executes as fast as possible. So this is good. A real reason why we have not been using this async attribute very much over the years is that it was new. It was HTML5. You never knew if you could use an HTML5 thing. But now, today, pretty much everything supports it, except IE 899. But I think we're at a time right now where we can let those go. And I mean, even if you put the async attribute into your page and the browser doesn't respect it, it would just get ignored. So it's not a case, like it would fall back semi-gracefully, let's say. So if there's one thing, I know I'm not sure that there's like a ton of takeaways from this talk sometimes, but if there's one thing that you can do, Google Analytics recently came out with an alternative async snippet. So you have to search for it. They didn't replace their default one, but using that HTML5 async attribute. You can use that instead, and it avoids these kind of like downloading scenarios, bad scenarios. So, man, this has been really quick. This should take more time, but I'm at the end. So, just kind of a couple closing thoughts. It's neat to learn about these things that have changed, and I think it's when I found them, I thought it was really neat. But that shouldn't be the takeaway to me. I think the takeaways should kind of be that, don't always believe what you read on the internet or in books or whatever. You kind of have to always treat everything with a bit of a grain of salt, and it's not enough to just take that as a good practice. You have to benchmark your own site. You have to experiment. A general practice from a couple years ago may not apply to your website. Even a practice from today may not apply for your website. So I'd encourage people to do their own experiments. And of course, do their own experiments every so often, because everything changes all the time. I'm sure that 3 years from now, we'll be looking back at 2015, and we couldn't believe that everything was so terrible. I hope so. I hope that's the way that we think. And always bet on browsers and JavaScript engines. I think that if there is a bit of a theme from some of the stuff that we've looked at today, it's like these are all kind of hacks around observed behavior from browsers at the time, right? And it's probably a safe bet that whenever you do something that could be kind of like qualified as a hack, at some point I think it will become bad. Maybe browser vendors recognize that people are doing this, and so they kind of account for it and make browsers better as a result of it. So that's all I've got to say about this stuff. Almost all the material, just a ton of material, is based off of research by a whole bunch of random people, including people I've kind of I don't think made fun of, but as much as people have written about this stuff in the past, they're still writing about it, and they're still writing new stuff. And if you're interested in web performance, I encourage following Ilya Grigoryk's blog, following Steve Souders, etc. Again, I work at a place called Sentry. You can check it out at getsentry.com, and that's all I have. My name's Ben. I'll be walking around. If you want to talk to me, that's cool. Thanks so much for coming. Enjoy the rest of the day.